Hey folks, I just wanted to go over the answers to our weather and climate practice test. And so let's dive into it. Question 1, a MT air mass would most likely originate over which type of Earth surface? So MT. So what we need to do is figure out what MT was, and that was from our reference table on page 13. And so that is going to be maritime tropical. So tropical meaning warm and maritime meaning moist. So we're looking for warm and moist. So number 1 was A. Number 2, here we have a map that shows a frontal system that has followed a typical storm track. So remember that the storm tracks go from the southwest to the northeast in the United States. And so the question for us is the air mass located over point X most likely originated over the, so if we follow back where X kind of came from, so it's this area, which is the Gulf of Mexico. So remember, air systems travel to the northeast from the southwest. And how do we know that? Well, if we just take a look at our global wind patterns here, the United States is between 30 degrees north and 60 degrees north, and the winds are going from the southwest up to the northeast due to the Coriolis effect. So number 2 was D. Number 3, an air mass from the Gulf of Mexico moving north into New York State has high relative humidity. What other characteristics will it probably have? Well, the Gulf of Mexico is a pretty warm area, so we'll have warm temperatures. We can automatically say B and A are not it. And those warm waters are going to want to evaporate and draw air up. And if the air is drawn up, that means below there's less pressure. So letter D. Number 4, which symbol would best be used to identify an air mass originating over central Canada? Well, central Canada would mean that it is in the middle of a continent, so it should be dry. And it's in Canada, so it should be pretty cold. So that should be polar. And so we're looking for continental polar, and that would be small c, continental, big one polar. And just to verify that, if we look at our page 13 from our Earth Science reference tables, continental polar, CP. Number 5, an air mass originating over northern central Canada would most likely be, well, this kind of ties into question number 4. So it's in Canada, so it's cold, and it's in the middle of a continent, so it's dry, and that gives us letter A for question number 5. Let's take a question number 6. On a weather map, an air mass that is very warm and dry would be labeled. Well, warm would make it tropical, and so we have 2 tropicals here, so that definitely takes off C and D. And dry means continental, so it forms over the continent instead of the ocean, and so continental tropical would be our answer for number 6, letter B. Number 7, we have a little weather map here. We have some different stations, A, B, C, D. We have our low pressure. We have these half circles. And then we have the triangles, and if you forget what those are, you can look to your reference table. So the half circles are a warm front, and the cold front is the half triangle. So behind this is going to be cold air. Behind the warm front will be warm air. So this will be warm back here, and this will be cold back here. Now the question is, which city would have the most unstable atmospheric conditions and the greatest chance for precipitation? So that means it would be a city that's closest to the fronts, because remember, a front brings in a change of weather, and we have warm fronts, we have some precipitation, but also cold fronts bring heavy precipitation. So which city is most likely closest to one of those fronts? And that would be letter B. So location B is actually answer C here. Number 8, the diagram below shows 4 points on a map with their relative positions to a low pressure weather system. So again, here's our low pressure. We have a warm front out front. We have a cold front right here. Which point is most likely having heavy precipitation? Well, if we look to our notes for fronts, we would see that the cold front, denoted by the triangles, is going to give us heavy precipitation. And if you forget what a cold front is, remember on page 13 of the reference tables, it tells you what the symbols are for each one of those fronts. And so the identifying feature is the triangles for a cold front, and the one closest to that is going to be 2. So location 2 is going to get the heaviest precipitation. Number 9, we get a diagram that represents the cross-sectional view of an air mass associated with a low pressure. Cross-section just means a side view. The cold frontal interference is moving faster than the warm frontal interface. What usually happens to the warm air that's between the two frontal surfaces? Well, we know that warm is less dense, so it's going to rise up. So as this cold air pushes in, it's going to push the warm air up. And the only answer for this is that the warm air is forced over the frontal boundaries. So letter D. So the warm air is forced under, nope. Forced under, nope. So warm air never goes under cold air because warm air is less dense and cold air is more dense. So number 9 is letter D. Number 10 here, we have a weather map. We have different locations, A, B, C, and D. They're going to ask us some questions. We have our low pressure there. We have our warm front, a cold front. We also have the different air pressures here, 996, 1000, 1004, and 1008. Each one of those locations has different little information on it. And so the question is, which weather station is experiencing clouds, heavy precipitation, and rapidly decreasing temperature? Well, if we take a look at this, we're looking for experiencing clouds and heavy precipitation. So we can see that automatically location B and location D are overcast, and that should be giving us some precipitation. And then heavy precipitation, or those should be giving us clouds, I'm sorry. Heavy precipitation comes with a cold front, and the only location that is by a cold front is going to be location B right there. But also we have to think about decreasing air temperature. Well, B is behind the cold front, and we know that behind the triangles there, that's where we have the cold air, so B is correct. So we have a lot of cloudiness. It's by the cold front, which brings heavy precipitation, and it's behind the cold front, so that means it's in the cold air, and that's why location B, letter D, is correct for question number 10. The weather station records a barometric pressure of 1013.32 millibars. Which diagram below would best represent this weather station on a weather map? Now remember what they do to the numbers. So I'm going to write this out, 1013.2. So what happens in this situation? Well, you get rid of the 10 and you get rid of the decimal, and that's the number written on the station model. So it's just kind of a code that each station model has that we have to decipher. So which station location has just 132 for the barometric pressure? That would be location C for question number 11. So here we have the information on this map. So again, a low pressure, we have our warm front out in front, we have our cold front here. So anywhere in here, we're going to have warm, and anywhere back here is going to be cold. So the question now is, the wind direction at station A is, well, let's go to station A. Here's station A, and the feather seems to be pointing straight out that way. So let's remember, north is this way, east, this is south, and this is west. So in between north and west is northwest, and the correct answer for that is going to be letter D for northwest. Question number 12. Number 13, the weather at station C would most likely be, well, let's go back to our map here. So location C, all right? Well, it's in the shaded area, so I know it has to be warm. It's 91 degrees and 86 is the dew point, so we could be having some rain there. And we have half of it is shaded in, so that's partly cloudy. So let's take a look for partly cloudy, warm, and maybe some precipitation. So I can already see partly cloudy for B and D. That means C and A are not it. And partly cloudy and windy, very cold. Nope. Partly cloudy and warm, so 13. So that's going back to our weather stations models. And if you have questions about those, page 13. This one just tells you what every single thing is. And then it also tells you what the symbols are related to it. So this is what it looks like on a map, and this tells you what the numbers mean. Page 13 on your reference table. Number 14, which weather station or stations is currently raining or drizzling at? Okay, well, again, we want to know where do we look for the current weather conditions. So here's our weather station model example, and the present weather is going to be right on the left-hand side, and there's a bunch of symbols that you don't have to memorize, but you can use. So rain or drizzle. So we have either a dot or a comma. So we're looking for a dot next to the big circle, or we're looking for a comma. And the ones that have that are location B, location D, and location E. So we have rain at B and D, and location E has some drizzle. Remember, page 13 reference table helps you with your station models. Which of the following, so question 15, which of the following statements best explains why climates at continental shorelines generally have a smaller yearly temperature range than inland climates at the same latitude? So we're talking about locations that are by the shore, all right, by the ocean. So say someplace like New York City, Boston, Los Angeles, compared to inland, which is maybe like us here in eastern New York State, or maybe in the middle of the country, somewhere in Nebraska. Let's remember that the temperatures change less on the coast. And that's because water has a high specific heat. And it takes a long time for the water to warm up, and it takes a long time for it to cool down. So ocean water changes temperatures slowly due to the high specific heat. So letter B. And if you're looking like, hey, what's high specific heat? Well, if you go to page 1, all right, on your reference table, look at liquid water, 4.18 compared to all the other numbers here. The closest one is 2. 4 is doubled, so liquid water has a very high specific heat. And we said if it has high specific heat, it kind of dampens the temperatures. It's not as cold or it's not as warm as the other places. That's number 15 is B. Number 16, we have kind of a map of an imaginary continent. The arrows are representing the prevailing wind direction, so which way does the wind blow there? Letters A through D represent locations on that continent, so A, B, C, and D. A and B are the exact same latitude, so it's the same north and south direction, so they're right here. And then they're at the same elevation, so the same up and down. We can see we have a mountain range right there. Let's take a look at the question. Number 16, over the course of the year, compared to location A, location B, location A will have, well, let's think about it. The wind is blowing in this direction, we can see that line, and we have some mountain ranges. So the wind has to go up. Now the wind is also coming from the ocean, so that air is going to be very moist. It's going to have a lot of moisture. And so when it gets to the mountains, it's going to have to rise up to go over the mountains. Now it's going to have to cool down because it goes up in the atmosphere. And when it cools, its dew point is going to increase. And when it rises, it expands and it cools and it's going to drop some rain. But now look at A compared to B. A is right on the coast. So its temperatures aren't going to change as much. So they're not going to fluctuate as much. The colds aren't going to be as cold and the hots won't be as hot. But now location B should be pretty hot in the summer and pretty cold in the winter. And the air is going to have to come back down the mountain, so it won't have as much moisture there because it's already dropped it at location A. So location B should be drier. So let's think about it. A, it should be much more precipitation, and the temperature range shouldn't be as much. So we're going to look at more precipitation. So B and A are out. And we're going to have a smaller temperature range, which is right here. So letter C for number 16. They're going to ask us a question now about the climate at location C and D. So let's take a look at climate at C and D. So C is right at 30 degrees latitude. And notice something, that the arrows are pointing away from location C. So the air is moving out. Remember, we have high pressure, and the air is going to move away from a high pressure. And if you have a low pressure, the air actually goes into, okay, a low pressure. So C is going to have a high pressure, and we said this is dry. Low pressures are wet. So we should find some conditions that are really dry at location C. And they want to know, the difference is best explained by the fact that location C is located, well, C is much drier, and it's at a latitude where air is sinking and the surface winds are diverging. Now, diverging just means, you might remember this from divergent from when we were talking about plate boundaries, but moving apart. And that's what's happening at location C. The air is moving in different directions. So it's a drier area. And so number 17 is letter B. Here's a question for dew point. So this is going to be in our reference tables. This is actually on page 12. I'll show that in a second. But the temperature of the dry bulb was 10 degrees Celsius, and the wet bulb temperature is 8 degrees Celsius. So what do we need to do? Well, 10 minus 8 equals 2 degrees Celsius. And so here's what we do. We start with 10, and we'll look on the up and down axis, and then 2 degrees Celsius will look on the left and right axis. So how do we do this? Well, I'm going to go all the way down to 10. My first column is 0, and then 1, 2. And so then the dew point should be 6 degrees Celsius. So again, I subtracted the dry bulb from the wet bulb, and that's 2 degrees Celsius. So I go down to 10, and I go over to 2. So I went down to 10, and then this is 0, 1, 2, 2 degrees difference, and that gives me 6 degrees for my dew point. And therefore, letter C is the correct answer. Here we say the air temperature of the wet bulb, they're both, the wet and the dry bulb are both 18 degrees Celsius. 2 hours later, the temperature is at 18 degrees Celsius or 20 degrees Celsius, but the wet bulb is at 18. So we have 18 degrees Celsius, 18 degrees Celsius. And then it goes from the air temperature is 20 degrees Celsius, but the dew point is still 18 degrees Celsius. So notice that there's no difference in these two. And so if it's at 0, that means you have a high humidity. So let's actually do this. So 18 degrees Celsius minus 18 degrees Celsius is 0. And so here's my relative humidity. So if I go down to 18 and I go over to 0, this is my 0 column, it's 100% humidity. So 100% humidity. Now 20 minus 18 is 2. So again, I'm going to go to my dry bulb temperature, which was 20, and I'll go over to 2, 0, 1, 2. And we have 82 degrees for our percent humidity. So it went from 100% humidity to 82% humidity, so therefore it is decreasing. Number 20. What's the approximate dew point temperature of if the dry bulb is 26 degrees and the wet bulb is 21? Well, 26 minus 21 equals 5 degrees Celsius. So this is my up and down, and this is my left and right. So let's go to 26 degrees down. So 26, and we'll go over 5, 0, 1, 2, 3, 4, 5, and that's 18 degrees Celsius for our dew point, and that makes letter D correct for number 20. 21, we're going to do some temperature conversions. Some folks really voted for that one. So a temperature of 73 degrees Fahrenheit is approximately equal to a temperature of, well, you got to know where to go in your earth science reference tables. And if you go to page 13 here, so here's 13, here's our temperature scales. And this tells you the temperature in Fahrenheit, and this tells you the temperature in Celsius. Now, we don't really use Kelvin, so we're not going to worry about that in this course. So we're at 73 degrees Fahrenheit. So I'm going to go here, 60, 80, and 70 is right in between. And so 72, 74. So it looks like if I go over to Celsius, it's around 22 or 23 degrees. And the closest to that is 23 degrees Celsius. There we go. Let's do another conversion now, but we're going to do a conversion with the barometric pressure. So we have an atmospheric pressure of 978 millibars. We got to figure out what is it in inches. So 978 millibars. So here's our pressure scale. On the left-hand side is millibars. On the right-hand side is inches. So 978. So we have 976, 977, and then there's 978. And if I go over, it looks like it's a 285, 86, 87, 88. So it looks like it's 28.88 inches of mercury, or close to that. And so our answer is, there it is, 28.88 inches of mercury. Here we go. We have another example. We had a decent amount of votes for converting Fahrenheit to Celsius. So 104 degrees Fahrenheit is what in Celsius? Well, we're around 100 right here. We'll go up 2 tick marks because they go up by 2. So 100, 102, 104. It looks like it's around 40 degrees Celsius. And 40 degrees Celsius is one of our choices. So 23 is letter B. Now 25, we talked about that the Earth is curved, and so the angle that the sunlight hits the Earth is different depending on your latitude. And so we can see here that the angle that the sun rays are hitting the Earth is at a different angle. Now, we said that when we have the greatest insolation or the most intensity of the sun energy is when the sunlight hits the Earth's surface perpendicular. And if you remember what perpendicular means, it means like we have a surface and we have another line, and that makes 90 degrees right there. And that's from math class. And so the one example here is that the letter D is going to show 90 degrees. So all of these have less amount of energy that's hitting every single part of the Earth, because when you come at 90, you're going to get the full effect of the sun. So the closer it is to 90 degrees, the more intensity you're going to get. And along the equator is actually where you get 90 degrees most often. You're never going to get the sunlight to hit the North Pole or the South Pole at 90 degrees. But you're along the equator, that's the best spot. So 24 is letter D. And our last one here, they're asking us which graph best represents the relationship between the average yearly temperature and latitude. Now, we just said that the equator gets the most sun's energy because that's the spot on the Earth that usually gets the sun's energy hitting it at 90 degrees. So there's not much of a difference in angle between 90 and the equator there. So if we look on our latitudes, we know that the equator is at 0 degrees north or 0 degrees south, whatever you want to call it. It's just 0 degrees. So on our graph, we should find that at 0, it is the highest temperature. And so if we look at A, no, they're saying it's hottest at the North Pole. This one's actually saying hottest at the South Pole. And this one's saying that the temperature at the North Pole, South Pole, and the equator are the same. Definitely not. It's definitely letter B. We can see that it's much hotter at the equator here, and then at the North Pole and the South Pole, it's colder because the sun's angle hitting the surface of the Earth right there is much smaller compared to 90 degrees. So letter B is correct for number 25. All right, so that does it for our practice questions. If any of those questions or any of the explanations for those questions does not make sense, let me know and we can talk about that as you guys get ready for our upcoming test.